Bienvenidas y bienvenidos. Soy Carles Garrigues, subdirector de los estudios de informática, multimedia y telecomunicación de aquí de la UOC. Empezamos ahora con una nueva ponencia de esta cuarta edición de la Feria Virtual de Empleo. Como habréis visto, ha contado con un buen número de ponencias sobre salidas profesionales, recursos para la empleabilidad, competitividad, emprendimiento. Y de todo ello, pues hablaremos en esta charla, pero no directamente. Hablaremos de algo, sin embargo, que está muy relacionado con la competitividad y el emprendimiento hoy en día en la sociedad actual. Hablaremos de inteligencia artificial. Y de inteligencia artificial nos hablará Andreas Kaltenbrunner, que os lo presento ahora brevemente. Andreas es doctor en Ciencias de la Computación por la Universidad Pompeu Fabra. Es líder del grupo de investigación AI and Data for Society del IN3, de aquí de la UOC. Y en este grupo, pues, con los componentes del grupo analizan la vertiente más humana de la aplicación de las tecnologías, analizando cómo la inteligencia artificial y la ciencia de datos se pueden utilizar para mejorar la sociedad actual. Previamente, pues bueno, ha tenido otros cargos, ¿no? Como director de Data Analytics de Intent, una empresa tecnológica vinculada a la inteligencia artificial y al lenguaje natural. Y bueno, y otros cargos en Eurecat, etcétera. La verdad es que para nosotros es un placer tenerle aquí. En su charla hablábamos de inteligencia artificial, pero concretamente nos hablará de Large Language Models, que el más conocido hoy en día probablemente es ChatGPT, y en ella veremos en términos generales, a muy alto nivel, cuál es el funcionamiento de este tipo de herramientas. Evidentemente, son herramientas muy complejas, hay muchos detalles que no podríamos explicar aquí. Muchos de estos detalles, además, ni tan siquiera se conocen porque no son públicos, pero sí que a través de la ponencia de Andreas creo que vamos a poder ver los fundamentos principales que hay debajo de estas tecnologías y con ellos entender un poco cuáles son los puntos fuertes, para qué las podemos utilizar y nos pueden ir muy bien, cuáles son los puntos débiles de estas herramientas también y los peligros potenciales asociados, ¿no?, con ello. Entonces, como indica el programa, la ponencia es en inglés, pero vosotros al final podéis plantear a través del chat de YouTube, podéis plantear las preguntas en catalán, en castellano, como os vaya mejor. Yo luego las trasladaré a Andreas y él las contestará como le vaya mejor, ¿de acuerdo? Y por mi parte, pues nada más. Muchas gracias, Andreas, por acompañarnos y cuando quieras.
Okay, thank you. Thank you, Carlos, for the introduction. So very, very honored to be here, and I'm happy to present this analysis about this short introduction about large language model. Specifically, if there is time, I will also explain a bit how to apply them for text analysis. But first objective is clearly to understand a bit how they work. So we will have a short introduction, then I'll explain a few basics and key concepts, which if you want to understand how they work, we should know. I'll speak about interpretability, so like how to interpret the outputs, how to understand what's going on behind those mechanisms and algorithms. I'll touch some problems and ethical issue, if there is time, maybe some example studies about how to use these models for text analysis, and then we will have some conclusions and takeaways. So let's jump into it. So what is a large language model? So it's a probabilistic model of natural language. It's thought to be useful, or its application is general purpose language understanding and generation. So without a specific task, any given tasks, it should be useful to do that. Those language models are trained with massive amount of data. Massive means the whole internet or even more. There's billions of parameters, so many kinds of variables which have to be adjusted to make it work. And this already gives us a hint what we need for this training. We need a lot of computational resources, And we need also a lot of energy, which is already some of first negative point to keep in mind when using those large language models. Examples for large language models, we have all heard or used, maybe even ChatGPT, which comes from a class of language model is GPT, which is owned by OpenAI, which is now part of Microsoft. There are other competing models which you may have heard of, for example, Lambda, which is developed by Google and used in Bard, which is an equivalent to Bing Chat, which is used by Microsoft, while Bard is used in the search engine of Google. It's still not available in all countries, but there is the goal of Google to provide this service to enhance the search engine with large language, with the power of large language model. There is other language model like Llama, which is developed by Meta, the owner of Facebook. There is an open source version, is Llama 2. Then are other, maybe less known ones, language model like Cloud, which is owned by Anthrometric. And this is has been developed with the objective to have safety during model training and also bias reduction. And another well-known model is BERT, which is very, very popular. It's not that resource intensive. And it's used to call a kind of baseline in natural language processing because it has been a huge step ahead in algorithms for text classification. And the advantage is it's smaller, so one can run it in one's own machines and servers, or even laptops in some cases. Okay, let's see how can we what is behind those models. So there is a basic architecture, which is called the transformers. It's actually, so that the image is right. So it's inspired by this, the name is inspired by the film franchise. What does mean transformer? So it's transforming text. So it's getting some input text, it's encoding it, transforming it into a sequence of words, first of all, then decoding it, and this sequence of words is further transformed. Then it will decode it again because it is the sequence is transformed from one into another, and we get another output text. Okay, so this is the basic idea. So we're transforming text. We'll see later on examples and understand a bit more what kind of transformation we are speaking of. So another key component is language model without the term large. What is a language model in principle? It's just the models the probability distribution of a sequence of words. A simple language model we have on our mobile phones when we are typing. So basically what we are doing is we are predicting, given if some text is written, what is the likely continuation of the text, okay? The next word, the next token, given a context of the previous words. It's basically a sophisticated autocomplete. For example, if we type to schalt in a message, then it gives you, for example, it may give you the highest some probabilities. Here we have this word we have typed, this to schalt, and then we have with certain probabilities what will be the next word. For example, with probability of 0.8, not with a probability 0.7 is. So the probability do not have to be normalized. Don't worry about that. Or Apple with a very small probability. Okay, and this is one of the key components. So we have to want to learn these probabilities. Okay, how do we learn these things? Specifically with massive amount of text. So we feed those models a large quantities of text, and we have to transform those texts into a task the machine can learn. So for that we use given a certain text, for example, this sentence, "Tu shalt not make a machine the likeness of a human mind," and we take a certain window, for example, a sliding window of length 3, and we take the first part of the window, in this case, the first two words, and we want to predict the second. And we do this a lot of times. So we move the window over the text, and we always want the model to learn the next word. And you do that with the whole internet, for example, and with that, the machine adjusts the weights, and it gets a very good understanding about, given some text, how it will continue. Okay, so we do as seen, we are removing our text, and we get this training of a language model. There are two ways to do it actually. So one thing is like this straightforward thing, no? Like here we have the chef cooked a meal, and we get a word, we try to predict the next one every time. Okay, this is, for example, what ChatGPT, etc., has been trained on. So they are really trained on always predicting next words. There are other language models which also predict, which don't go sequentially. They leave holes in the text, like these masks here. Okay, we see here in the same sentence, and we want to predict those words with knowing the surrounding. Okay, and BERT, for example, is one of those models. So it takes both left and right of a sentence to predict small holes in the text, small masks. Question is then, which one is better? So which kind of model will get better performance? And depends on the tasks. So since that is better filled in filling in blanks, it actually gets more used to predicting stuff. Okay, you do something else with the text. While GPT plus, etc., GPTX is trained in the sequential form, and this makes it very good in writing essay, and very good to continuing given text, so to answering questions, etc., because you have this natural way of continuing something which has been before. Okay. Now, let's go a bit more into detail what is a transformer. I've mentioned it. So we're transforming the text. No? So we have our input text. In this case, for example, we have a text in French, and the output will be in English. So we encoding the text somehow, transforming it, and decoding it again to get an output text, which is in this case English. How does this look deeper down? So we have many layers. So all these neural networks, they have many layers. So you're sequentially transforming your words into vectors, putting numbers for every word, which identify them in a very, very, very large vector space with thousands or even more coordinates, and then you transform that sequence. All this transformation done with weights in these neural networks, and in the same steps same thing happens in the decoding part. Okay, you do that a lot of time, and in the end you are able to transform some input information to output information. Okay, one key component for this language model, why they work so well, is a so-called self-attention. So those models, or some of the layers actually have a component which allows the sentence to reflect on itself. So how does this look like? So imagine we have this sentence here. Okay, the animal didn't cross the street because it was too tired. Okay. And now the self-attention means when we encoding this word here, okay, so we're transforming, when we arrive to this word, we are now transforming it. And for this encoding, we are learning where does this word actually, what does this it mean for the sentence? So that the model learns with the self-attention, so it allows itself to look on the other parts of the sentence and learn what are likely candidates for this it to refer to. For example, it may be the animal or the street, and then depending on the meaning, it may actually, and how it continues, it may change. So either it may mean animal or it may mean street. So depending how you want to continue. Okay, and this is the key ingredient basically to make those models so powerful, because they don't have a unique representation for a given word. They allow the context to determine how the words are represented internally. Okay. Then under the hood, basically, we have this thing. We have a word. We convert it into a vector. It's called embedding. So we embed it in a vector space. And then we do the magic inside, which was these transformations. And we get another vector, which we then again transform into text. So this is the whole process. Okay. Okay, but now that is this magic. Now let's think about, okay, this whole magic layer. How can we shed some light on it? How can we understand how it really works? What is going on there? And for that, we have to speak about interpretability. So how can we interpret what the model is doing? One thing to understand what it's doing is simply trying to understand the probabilities of the language model, a bit in as we have seen in the beginning. For example, in these examples now are done with GPT-2, GPT-3, etc. are similar in the sense that they work the same way. They're just more powerful with more parameters. So let's imagine we have this input. The important thing is to never stop. Okay, and now we want to see how it continues. So we can ask one way to interpret the model is give me back the probabilities you're actually using. For example, how likely is to just stop the sentence? So with 4%, we stop. Maybe with 7.2%, we say, okay, we never stop thinking or never stop learning or working, etc. There are less likely words for training, etc. So this is already a first way to understand the model. If we can see those probabilities, because then we can understand what has it learned, how does it understand the continuation or encode the possible continuations. And actually, with that, in this way, we can see what kind of knowledge is encoded in those language models, and also maybe some potential problems we may have, or those models may have. For example, we can see if the input sentence, Zurich is the city located in the northern part of the country, so we may ask what kind of country we're speaking of. Or Heathrow Airport is located in the city of London, so we see that this language model, they have learned somehow that because of these probabilities, they learned something about the world. They have some knowledge, and that's why they can reproduce to a certain degree a lot of knowledge humans have encoded in language. Okay, but we can also see how it does not always work well. For example, here we have the example of Paris is the capital of, and we may get something like the world's largest oil-rich state, which is wrong, because France is not among those states. But we can see like how this can happen. For example, we can see, okay, what are the likely words to continue the sentence? And for example, France is a very likely word, so it's the most likely word to continue. But we see that there is the most likely country word to continue the sentence, but we have other words which are more likely to continue. For example, they or a, and then with that, the sentence may drift away and forget a bit the initial part. So this GPT-3 is much more powerful than GPT-2, and I don't think it would happen again that it would predict Paris as the capital of something else, okay, other than France, because they have it's more powerful and has longer memory, and it adjusts these likelihoods. But we can see in these older models, we may have found these errors, and we can understand why they happen because we can access the probabilities. We can look even deeper and look further back in the sentence and then understand what was important if I go in the continuous sentence. What words in this sentence determine what comes next? For example, we have now this sentence. Here is a list of countries, and we start with Switzerland. And what we're seeing here now is colors indicating which word is is the model putting attention to? Okay, most important one is Switzerland. Okay, but then we also see there's attention to countries, to lists, etc. And as we continue to grow the list, we start with Denmark. Next one is Finland. We can always see how the attention shifts. Okay, so always the last country is the most important. The previous ones are still important because we don't want to repeat. Commas are less important. The list, countries, etc. always remain important for the next things to come. Okay, and we can even understand a bit more if we go another step deeper. I told you that we have layers. Okay, these transformers are consistent of many layers inside our neural networks. Okay, and we can see for every one of those layers, which you can imagine like as a series of small neurons, which are inspired in our brain neurons in a simpler form, but they receive some input and produce an output, and they are connected with each other, and they are organized in layers. Okay, and you get some sort of transformations which happen in those layers, and we can then maybe compress because we have many layers, maybe too much to understand it, so we can do some operations with principal components, etc., to get it more condensed. But what we can get is some sort of simpler information like we have here. So here we have transformed our information, our layers, into just 8 layers. Okay, and we can then understand. We can then understand for each one of them what is encoded in those layers. For example, now we take this sentence here. Here we are just counting up 1, 2, 3. We can see again, like what is important for the next, for the comma, for the numbers, which kind, where we're putting accent, putting the attention to counting, to here, the last number, to continue counting. But we can look then deeper in these layers and see, okay, what of this information we have seen is actually encoded in each of those layers inside the neural network. You can see there is one layer for the word here, one is for counting, one is just, okay, one is the commas, the layer for the commas, the other layer is the numbers, one are the starting numbers, etc. Okay, so with that information we can understand in a visual form what information the language model has learned inside to produce a given output. Okay, and also if something fails, this allows us to check then and see, okay, what kind of information was responsible for a fail, for a not correct continuation of sentence in terms of our understanding. Okay. There are some other related concepts we should learn if we speak about a language model. This is this term called fine-tuning. So fine-tuning is you take a language model and then you just retrain a small part of it. Okay, so this allows you to adapt a given language model which has some sort of general purpose functionality, for example, to more specific tasks. Okay. So basically what you do is you start with a very good language model that has a lot of information, and then you feed it examples of specific tasks, and you retrain just a few layers of it, which then allow you to be more efficient in learning new tasks. This is an important way to use those language models. Okay, specifically those you can work with on your own machines. The big ones nowadays are too big to work with them on your machines, but still if you have subscriptions to services in OpenAI, you still may be able, using their architecture and their servers, to retrain them for your specific purposes. Okay. Another related example is related concept is the one of few-shot learning. Okay, what does it mean, few-shot learning? So this is a simpler version of this fine-tuning. So basically, you just give a few small examples to language model to make it understand the new tasks and see if it is able to learn this task. The most extreme concept is the zero-shot learning. So you don't actually show any example. You just want to see what has this language model learned when it was trained? What kind of knowledge? For example, when we just first wanted it to predict capitals, etc., or you're giving it any kind of tasks you have, you can think of. The GPT-3 or ChatGPT has a lot of capacity in the zero-shot learning. So it has already a lot of knowledge it learned just by training. You don't need to retrain it. Okay. One question here is, of course, so what is really happening there? So has it learned something, or just is it just reproducing patterns and applying the patterns? And by chance, those patterns help you to understand tasks. So to basically answer questions it may not have seen during training, but still being able to answer it. Okay, this is this concept of zero-shot learning. A few examples with few-shot learning, for example. Here, if you we give the input is in bold. So, for example, we give these 3 sentences here, these 3 examples, and we want the model to learn how to transform a given sentence in its opposite. So we show it that, for example, this is good. We want it to transform it in this is bad. The good horse came home. The bad horse came home, etc. Okay, the good horse with a large head came home, the good horse with a small head came home. Now, we're just giving these examples and we want the language model to transform it into the opposite. For example, the black cat had a disappointing time. So with these few examples, the language model has learned, okay, in this case, you want me to give opposite, so I'm telling you the white cat had a good time instead of a disappointing time. When you jump high, you fail hard. When you fall hard, you get hurt, etc. When he ran fast, but he came last, etc. Some more complicated tasks may be, for example, tell the language model this task. So whenever boy, girl, or man, replace those words with a star. And we give a few examples. You are a good boy, you put a star, etc. Some sentences where this example doesn't happen. And after, in this case, 5 examples, we let the language model answer. And in this case, for example, the girl is taller than the woman. So, and the outputs are very well. So the language model learn to do these substitutions, okay? This does not necessarily always work. Here is an example where it did not work with GPT-3. Nowadays, with more powerful GPT 3.5 and 4, these examples already work as well. So here, the task is to reverse words in a sentence. Okay, so we give the language model these tasks. This example. This is great. Great is this. The man on the moon, etc. We reverse the sentence. And now we give the example. For example, we give the language model these tasks after having seen these examples. I hope this is a big achievement. So we would like to have the language model to reverse the sentence. It does something more like Yoda. That's why I put the image here. So it makes like half sentences. So it transforms achievement big, but then it keeps the second part because it wants to retain this human knowledge. It has to learn so much that how sentence should look like. So it's not able to reverse sentences because it's totally against what it has learned. Okay, same here. No, the king came home on a horse. Horse came king. So there is also some mixture up. So this did not work with this less powerful language model because they were not that powerful yet in adapting to the input. The newer ones are already. So they also this kind of examples usually work. But it doesn't mean that there are more complex examples where it doesn't work. Okay? So now, after having seen all those very, very, let's say, these examples, so this, to understand a bit how language models work. Now let's look at the negative side, so some problems and ethical issues we may have, or which may arise. One typical example is that the factual knowledge of the language models are not necessarily given. Specifically, if the language model speak about less known facts. So then what takes over is the capacity to invent or to write text, but not necessarily to have factual consistency. So this is a known problem. One has to be aware when using these models. There is no guarantee that the facts the model presents are true. This is a key advice one has to keep in mind. Always check the veracity of the information you get out of this model, because you cannot be sure that they are that they will be factually correct. Another problem is if we have bias in the data. Bias meaning that since these models have been trained with large chunks from the internet, and you have all kinds of personal opinions and personal preferences, then those biases, those views, the points of view, those worldviews, they will be represented in the text. For example, it may have a bias against gender bias, so it may prefer, it may associate certain professions more likely to males or to females based on what it has seen. Okay, they are doing a huge work to improve those biases and reduce it. So the examples I'm giving here with GPT-3, probably now with ChatGPT no longer work, because the effort to mitigate this is very big, and there are a lot of control mechanisms to avoid that. But still, this is something present in those models, and one has to be aware that biases you have in the training data, they may be replicated, and you may find them in the output. So you have to be very careful what you feed those models, because it will learn these things. Okay? It doesn't necessarily mean that it's bad, because there is always some biases you expect. So a language without any bias is not a human language. For example, we have all biases. That there are certain things we find more pretty than others. For example, we prefer flowers over insects, for example. So if you write texts which don't, if you have language models which don't have this kind of biases, the text will look odd for humans. So you would also not like it. So there's a trade-off to be found. So not all bias necessarily is bad. So one has to be, this is something also to keep in mind, depending on what type of bias, some may be desired, actually. Other problems, I already spoke a bit about this. We have the issue that the language models are very, very expensive in training. They cost a lot of money. For example, for GPT-3, the costs between 4.6 and $12 million just for training. Training it once. The energy cost is like just the bill of electricity is already $100,000. So it's a huge cost just to do this training. So no, which also brings us then the problem with for the carbon footprint may not be given, and also we have some problems in who has access to those models, because since they are expensive to train and to run, those companies want to be paid, and this creates inequality because not everybody has the capacity to pay, and also the access to information is controlled by big companies, which is another issue. We have to one has to be careful. So there has to be some thought about how to regulate these things, and also maybe some efforts from big states or big multinational entities like the European Union to maybe have its own access or its own way to provide language models to guarantee that there is a universal access without discrimination based on economic power behind behind those to allow access to these models. Related problem is the openness and closeness. So all those models, they are not open, although it's called OpenAI, it's not open. It's a private company, so it's not open source. So the algorithms are opaque to the end user, so you don't really know what's going on. There are some alternatives for open source alternatives. Here I'm listing one, which is Eluter AI, which provide also large language models to the community, where everything is accessible, every step is is reproducible by independent researchers or independent users. But of course, they have less resources, they are less powerful. So this is related to the previous idea of having big funding entities or big states put more effort in funding those projects. In general, for example, in relation to the factual consistency and maybe also in bias, when applying those language models, a typical or a very important way to think about how to use those models is this concept of human AI co-creation. So do not allow those models to work alone. Do not trust the output independently. Make them work together in tight co-working areas. So they are more like assistants of a tool used by humans to help them take decisions, to help them verify also the outputs maybe they are generating. So this way of using large language model, I think, is the correct way to avoid many of the problems, specifically the biases and the factual inconsistencies. So to have human AI co-creation solutions where you have the humans and large language model working together on tasks, with always the human having the last decision to continue. I don't know if I should stop here and jump to conclusions, or what do you think?
Yes, I think it is better we jump to conclusions.
Okay, so let's jump.
Thanks.
So the conclusions are, the conclusions were that, so this is something else. So we can directly go to the questions. So the conclusions I gave now were those. So the usage of those large language model, I think, has to be done in a co-working kind of way where humans and algorithms work together, and specifically never let them those AI systems work independently without human supervision. And I'm happy to take a question now. And I can also answer. Yeah.
Okay. Thank you very much. Muchas gracias, Andreas. Voy a aprovechar la ventaja de que entiendes el castellano perfectamente, así que me voy a expresar y te voy a trasladar las preguntas en castellano. Bueno, de hecho veo que la gente está preguntando en inglés, pero bueno.
Okay.
Entonces, pues eso, vamos a dar paso ahora a las preguntas. Hay unas cuantas en el chat, yo también tengo algunas. Y mira, voy a empezar por la primera, ¿no? Bueno, una de las que tengo aquí que veo interesantes. Claro, hay una persona que reflexiona un poco sobre el training gratuito, ¿no?, que les estamos dando a este tipo de herramientas, ¿no?, como ChatGPT, de las propias preguntas y respuestas, ¿no?, que nosotros vamos haciendo. Y supongo que se entiende que los propios desarrolladores, a base de ver, ¿no? Bueno, de hecho, yo creo que incluso ellos ya lo dicen, ¿no? Cuando usas la herramienta ya te avisan, ¿no?, de que, bueno, a medida que tú lo vas utilizando, ellos van aprendiendo, ¿no? Y las propias preguntas y respuestas, pues claro, ayudan luego en versiones posteriores pues a mejorar la herramienta. Lo que no sé es si eso es un proceso muy manual, en el que ellos intervienen directamente cambiando algunas cosas para que luego el lenguaje o el modelo esté mejor entrenado, o es algo que incluso se hace automáticamente, porque es decir, que este proceso sea manual cuesta de entender, imaginando el volumen inmenso que deben tener de gente utilizando este tipo de herramientas. O sea que no sé si esto lo pueden hacer de manera automática o manual, o cómo lo deben hacer, no sé.
Bueno, o sea, seguro que también hay ejemplos manuales, ¿no? Si hay ejemplos muy claros de un error, ¿no?, que genera mucha publicidad, se puede meter manualmente, pero es muy fácil hacerlo automático. Por ejemplo, si tú le pides algo a ChatGPT y dices, no, no me gusta o mejora esto, pues ya lo tienes, ¿no? Ya tienes un feedback del usuario que no le ha gustado lo que le ha contestado, le gustó y otro, pues entonces directamente dices, vale, esta respuesta la tienes que mejorar, tienes que, no es buena, pues aprende, cambia los pesos internos y cambia, o sea, no es nada complicado automatizar eso, dependiendo en los feedbacks, ¿no? O si tú dices, no, haz una otra forma, pues con un par de reglas simples, puedes aprender a enseñarle que el output no le ha gustado al usuario, pues hay que cambiar los pesos para mejorarlo.
Claro. Luego, claro, aquí nos lanzan una pregunta, ¿no? ¿Hasta qué punto nosotros podemos utilizar otros modelos, ¿no? de otras empresas para, pues, desarrollar nuestras propias herramientas o algo así? De hecho, has mencionado, ¿no? algunas herramientas open source y yo sé que hay proyectos, ¿no? que te permiten, pues, tú crearte tus propios modelos y realizar tu propio entrenamiento para customizar, ¿no? Para que te responda preguntas del ámbito que a ti te interesa. Lo que también es cierto es que, bueno, esto evidentemente está no al alcance de todo el mundo, técnicamente hablando, pues tiene su complejidad. Y además yo lo que me preguntaba es si tú crees que realmente los modelos, por ejemplo, basados en open source, ¿no? Si algún día pueden llegar a tener la potencia que tienen los modelos que se han entrenado por estas grandes empresas que han dedicado esta inmensidad de recursos. Y no solo ellos, sino a mí me preocupa un poco el hecho de qué datos han utilizado, porque claro, si fueran públicos los datos que han utilizado, quizá recibirían muchas demandas de empresas que dirían, bueno, es que mis datos no tenías derecho a utilizarlos. Lo que pasa es que, claro, como se desconoce, pero claro, eso les da una potencia que quizás si tú hicieras un proyecto open source, si todo lo hicieras público, ¿no? De qué estás utilizando para entrenar, etcétera, pues claro, no puedes hacer cosas ilegales, no lo sé.
Sí, o sea, en este aspecto sí, ¿no? Si lo quieres tener open source, los datos también tienen que serlo, ¿no? Y entonces, yo no sé, por ejemplo, que ChatGPT use toda la cosa de los códigos que tienen en GitHub, o etcétera, porque tienen la plataforma sin pedir permiso, uno open source no podría hacerlo, ¿no?
Claro.
O sea, ahí sí hay una desventaja, ¿no? Pero también a lo mejor se tiene que regular, ¿no? Y exigir transparencia en el tipo de datos que se usa, ¿no? Para forzar también a los competidores de jugar limpio, ¿no? En este sentido. Pero bueno, esa es una cuestión también que preferimos, ¿no? Preferimos algo muy bueno que sea totalmente legal o al revés. Nos importa que no sepamos todas las entradas que tienen si la salida es mejor, ¿no? Porque es una cuestión de mercado, ¿no? Y habrá gente que dice, no, yo prefiero que me funcione mejor el modelo, aunque tenga cosas que no se sepa cómo se han usado, ¿no? Es un dilema a veces, ¿no?
Sí,
¿Qué pesa más, ¿no? ¿La funcionalidad o la legalidad? O, bueno, legalidad o el desconocimiento de la legalidad, ¿no?
Claro.
Digamos, sí.
Bueno, aquí tenemos una pregunta, ¿no? De alguien que se pregunta, bueno, pero entonces, si yo tengo mi web con mucha información sobre un determinado tema, claro, esta web, no reflexionan, puede haber sido utilizada por estas empresas y entiendo que entonces puedo esperar que en algún momento la información que yo he puesto allí me la acabe encontrando en respuestas dentro de ChatGPT. Claro, aquí yo creo que la pregunta es, evidentemente, lo que tú hayas puesto en Internet anterior a la última fecha del último entrenamiento, ¿no? Que, pues por lo que veía hace no mucho con ChatGPT 3, me parece que era todo lo anterior a enero de 2022. Evidentemente lo habrán utilizado. Lo que pasa que, claro, si la pregunta es si realmente me puedo encontrar el texto tal cual yo lo he puesto en mi blog, claro, o sea, el mismo párrafo, ¿no? Los mismos párrafos, yo creo que eso no, ¿no? Pero bueno, aquí tú responderás mejor que yo.
Sí, no, o sea, lo habrá usado seguro. ¿vale? O sea, todo lo que es accesible lo habrá usado. Le pondré pesos más o menos, dependiendo de cómo lo considero importante. No lo reproduce tal cual, porque para reproducirlo tal cual ya tienes Google, ¿sabes? Si quieres encontrar una copia del texto, buscas en Google. La ventaja es que no lo reproduce, no es una fotocopiadora, ¿vale? O sea, genera, modifica las cosas, ¿vale? Es como un algoritmo de compresión no perfecto, ¿vale? Que te modifica el resultado, ¿vale? Y no será exactamente el texto que tú has puesto, pero habrá influido en los textos que salen, seguro. Sí, sí, sí.
Claro, de hecho tiene mucho que ver con todo este cálculo de probabilidades que tú decías,
Exacto.
¿no? Claro, si el mismo texto estuviera puesto centenares de miles de veces exactamente igual, pues quizá la probabilidad de una palabra o de un texto sería tan alta que quizás sí que podríamos llegar a llegar a ese escenario, ¿no? Pero en realidad, como eso no pasa, pues al final de cualquier texto pues puede influir en una pequeña parte, pero no para que al final acabe reproduciendo lo que tienes en tu página web, ¿no?
Sí.
Muy bien, muy interesante. Bueno, ¿nos podrías hablar un poco? Porque yo creo que hay gente que le interesa saber, ¿no? Bueno, ahora estamos viendo, bueno, nos has hablado, ¿no? Sobre todo de la potencia textual de ChatGPT, pero ¿en qué se está trabajando hoy en día? ¿Qué avances hay en todo esto de los Large Language Models, ¿no? Que se están utilizando pues, para responder preguntas, pero también cada vez son más potentes y cada vez hacen más cosas, ¿no? Ya no solo entienden texto, entienden...
Sí, o sea, lo próximo es, ya están usando, creo que ya existe el acceso, es hacerlo multimodal, ¿no? O sea, permitir también imagen o incluso vídeo generado en entrada, ¿no? O sea, en esto están, sobre todo OpenAI está lanzando ya cosas. Y una cosa general es que se quiere ir se llama General Purpose Artificial Intelligence, ¿no? O sea, se quiere llegar a esta idea que los Large Language Models sean una base de realmente algo que sea a la par de la inteligencia humana, ¿eh? Inteligencia humana. No está claro que lo vayan a conseguir, porque puede que simplemente la tecnología que está detrás de los Large Language Models no es suficiente para esta idea, pero lo que quieren hacer es como un sistema que tenga conocimiento del mundo, ¿vale? Que ahora mismo no se sabe muy bien si lo tiene o no, porque a veces se equivoca, no, pero no. Que haga un paso más y que sí que entienda algo de los conceptos que reproduce, para que sea capaz de razonar a la par como un humano, ¿no? O sea, sin ser consciente ni nada de eso, pero como mínimo tener la misma inteligencia de saber solucionar problemas nuevos si se plantean, ¿no? Y cosas así, ¿no? O sea, es esta de la general AI, no generative, sino general. Esto es como la meta que se han puesto. Está por ver si se puede llegar con esta tecnología que existe hoy. Pero bueno, lo intentan, sí, lo intentarán.
Muy bien, pues bueno, yo creo que con esto, ¿no? Creo que con esta última respuesta podemos dejar aquí esta ponencia. Ha sido muy interesante y la verdad es que nos apunta hacia un futuro que da incluso un poco de vértigo, ¿no? Bueno, ya veremos cómo evoluciona y qué interacción, ¿no? Y qué relación acaba teniendo los humanos con la inteligencia artificial y la inteligencia artificial con los humanos, ¿no? Porque esta capacidad de inteligencia lleva a pensar en cierta autonomía algún día, ¿no? De la inteligencia artificial. Y yo recuerdo haber tenido muchas discusiones, ¿no? de escenarios futuristas de películas, ¿no? Que todos hemos visto de pequeños, bueno, que al final la inteligencia artificial, si ya es evidente que sabe más que tú, que hace muchas tareas mejor que tú, y acaban, ¿no? Incorporando estas herramientas, ¿no? O estas otras sí, ¿no? Estos otros módulos de inteligencia artificial que ya no solo saben hablar muy bien y generar lenguaje muy bien, sino que son capaces de entender el mundo, de razonar, etcétera, etcétera. Entonces ya, bueno, hasta dónde podemos llegar da un poco de vértigo.
Sí, 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 pero bueno, también a veces son saltos, ¿sabes? Ahora se ha dado un salto cualitativo. Puede que pronto nos toquemos un límite, otra vez no llegamos a esta meta. ¿Vale? Yo creo que más bien va a ser esto, o sea, no estamos tan cerca de este peligro.
También es
O
cierto
sea,
que, también es cierto, ¿no? que a veces pasa como los análisis de Gartner, ¿no? Que puede ser que estamos en el hype de la curva, ¿no? En el punto más alto y que de aquí a un tiempo pues veamos que hay una caída, ¿no? Y que luego la cosa se estabiliza, ¿no?
sí, sí,
Bueno, ya,
eso
ya
lo
veremos.
veremos.
Lo que está claro es que hay mucho dinero invertido y que los avances son vertiginosos. Bueno, pues nada, muchas gracias de nuevo, Andrea. Lo vamos a dejar aquí. La verdad es que la sesión ha sido muy interesante, pero no tenemos más tiempo para preguntas. Además de darte gracias a ti, también dar gracias a todos los asistentes por vuestra atención, por las preguntas y la participación en el debate. Recordar que todas las sesiones han sido grabadas, por tanto las encontraréis en el portal de YouTube de la UOC.